Marissa, thanks for another question. So for the first line of our proof, we're going to utilize the information that they're giving us. They tell us that PQ, this line right here, bisects both angles SPT and angles SQT. Now if it's bisected, the angles on either side are going to be congruent. So that's basically what we're stating. That angle SPQ is congruent to angle TPQ, and that angle SQP is congruent to angle TQP. For the second line of the proof, we're also basically stating the obvious, which is that if you split the triangles up on either side of PQ, that they share the side, therefore that side is congruent. So we're just stating that for our second line, that triangle SPQ and triangle PQT share side PQ. For the third line of our proof, we're going to be using a theorem called angle-side angle. So if we split the triangles on either side of the line PQ apart, and then if we rotate them slightly, we can get them into a position where we have corresponding sides and angles that match up. So it's easier to look at. So we can see that these triangles share two congruent angles and a congruent side, which is the angle-side angle theorem. So by angle-side angle, triangle SQP, or SPQ as we called it, let's go ahead and call it that, is congruent to triangle PQT. For the fourth line of our proof, we're going to be using something called corresponding parts of congruent triangles are congruent, which is totally a mouthful. So we call that CP-CTC, which basically means that once you prove that two triangles are congruent, you can then match up the sides and angles and you can say that they're all congruent. So we can look at side, say, SP and side PT here and here in these triangles, and we can see that these are clearly corresponding sides of congruent triangles. So by CP-CTC, SP is actually congruent to PT or TP, and that is the end of our proof. Thanks again for your question, Marissa, and I look forward to answering more of your questions using SnapMath in the future.